Since this is the last section of Chapter 7, I thought I would do a little bit of review for you. So let's just get right into it and talk a little bit about everything that we've done so far this chapter. So we started off this chapter by just talking about functions. We said that a function is when every x value has only one y value that goes with it. And then we talked about how the x values are called the domain and the y values are called the range. So we used the vertical line test to help us out, and that just means that if a vertical line crosses it more than once, it's not a function. So we can see that this is not a function, this is not a function, and the rest of these three pictures were. Then we talked about function notation, where instead of writing y equals 5x plus 6, we're going to use that f of x equals 5x plus 6. And remember, we use this because we can just then say f of 3, and that just means the same thing as evaluating the equation y equals 5x plus 6 with x equals 3. It's just a lot quicker and it's a lot more efficient. And then the last thing we talked about was absolute value, and we talked about this example with Cal and Al where absolute value just tells you the distance from 0 on a number line. So it doesn't matter if it's positive or negative. So for example, the absolute value of -5 equals 5, and the absolute value of +5 equals 5, because they're both 5 away from the number line. So what we're going to talk about today is squares and squaring and parabolas. So it says, think of a number between 1 and 10. Multiply it by itself, and what number did you get? So I'm just going to pick one number. I'm going to pick 2. So if I take 2 by itself, I get 4. Then it says, try it again with the opposite of your number. So -2 times -2, and it says, oh, that also equals 4. So it says, did you get the same result? Well, obviously, yes, I did. So this is called the square of the number. So instead of saying multiplying a number by itself, we call it squaring it. And that's because when you talk about a square, 2 times 2 gives the area of a square, 4. So the process of multiplying a number by itself is called squaring. So the square of a number is x squared, and you write it as to the power of 2, or x squared. So that's why we call this x squared. So I could say that 2 squared equals 4. Now the last thing that I do want to point out is this last part. It says, try entering -3 to the second power and parenthesis -3, close parenthesis, to the second power on your calculator. So don't worry about trying it in a calculator, but I just wanted to point this out because actually the second option is what's going to actually square the -3. It's what's going to take the -3 times -3. This other one will end up giving you a -9, which is not what you're looking for. When it comes time to do it on your calculator, you want to make sure you put that negative into parentheses before you do the exponent. Okay? So here's your vocabulary this time. We already kind of talked through it. The square of a number is the product, or the process of multiplying a number times itself. So for example, x squared is the same thing as x to the second power, which is the same thing as x times x. And then this gives us a special type of graph, and the name of this graph is called a parabola. And that's just any function where it says in a family of functions with the parent y equals x squared. And all that really is saying is that, remember previously all of our equations have been more along the lines of y equals mx plus b. They all just have an x to the first power. And all of those are in that form, and they are just linear. And a parabola, we're going to see the shape of it in a minute. I'm going to graph it. But they're basically all going to look the same way, and they're going to have an x to the second power. So they might have different coefficients, different things added, but the basic parent, or the basic graph of a parabola, comes from squaring the x, or taking the x to the second power. And you're going to start seeing a lot more of these as we move further into algebra and advanced algebra. And then the last piece of information, or the last vocabulary, is the square root of a number. So the square root of a number is the opposite of taking a number squared. So every positive number has 2 square roots, because if you go back to my example where I said that 2 squared was 4, as well as negative 2 squared is 4, that means that the square root of 4 could mean that I either took positive 2 or negative 2 squared to get it. So it's just kind of working backwards. Asking you for the square root of 4, it's really asking the question, what number squared equals 4? And that could be a positive 2 or a negative 2. So you see our example here that the square root of 36 equals positive or, sorry about that, equals a positive or a negative 6. So go ahead and pause this for a minute if you need to and write down those examples, and then we'll move on to what a graph of a parabola looks like. So what I've got set up here is I've got a basic x and y axis, and then I've got a t-chart set up, and I'm just going to graph y equals x squared. That's the parent graph of a parabola. We're going to graph a parabola. And maybe some of you have heard of this term before, but I'm going to just start with maybe a negative 4 for my x, and I'm going to go all the way through to positive 4. So negative 4, I'm just going to take x squared to get my y, so I'm going to take negative 4 squared, that gives me 16. Negative 3 squared gives me 9. Negative 2 squared gives me 4. This gives me 1. 0 squared is 0 because 0 times 0 equals 0, right? Okay, and 1 squared equals 1. 2 squared equals 4. 3 squared equals 9. And 4 squared equals 16. So let's go ahead and graph those. There they are. And then I'm going to go ahead and graph also 5 and negative 5 squared, because I see that it can fit on my graph. So negative 5 squared would be 25. So I'm going to graph that all the way up here. And 5 squared would also be 25. And so what you see is that it starts getting bigger and bigger pretty quickly. So 6 squared is going to be 36. That's going to be an even bigger jump. So it's going to be increasing at a rapid rate. So it's not linear anymore. So I'm going to carefully draw in my lines here. And I've got this sort of U shape. This is what all parabolas look like. Some might be skinnier or fatter. They might be shifted up or down or left or right on the axis. But this is a parabola. It's a new type of function that you come up with when you square a number. So maybe let's go back to your vocabulary page, and next to the parabola, why don't you just draw a picture that looks kind of like this as a parabola next to it. All right, so we've got one more example. It says, find the side of a square whose area is 81 inches squared. So I know that what I'm looking for is a number, x, for the side. And what I know about squares is that all the sides are the same, right? So all of these sides are going to be equal to x. And I know I get an area of a square by multiplying side times side. So that means x times x. So x times x, okay, and I know that I can write as x squared equals 81. So I'm looking for what number squared equals 81, which if you're like me, you probably can look at right away and just know what the answer is. But it's important to know that we need to do the opposite of squaring to figure this out, which means we need to take the square root of each side. That'll leave us with just an x over here, and square root of 81 we know is 9. And we've got our side length. Obviously, it's not going to be the negative answer that will apply in this case, because you can't have a negative side length for an area of 81. So in this case, our square root just gives us the answer of positive 9 in this situation. So go ahead and use the same process. Try it on this one. Find the side of a square whose area is 6.95 centimeters squared. And we are done with